So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now, the biggest source of greenhouse gas emissions in homes and offices is a natural gas furnace. Over the past 50 years, natural gas almost completely replaced oil as the best source for space heating. Heck, I remember as a kid when we had this oil burner in our basement, the vent pipe fell out and filled the house with oily smoke. So the natural gas was much cleaner. And going back 100 years, we had coal boilers in the basement for space heating. I mean, not my house, but that's the way it was. So as technology improves, we get better and better heating and cooling systems. And without a doubt, heat pumps are the best way to heat and cool buildings. These systems have improved dramatically over the past 40 years. Most common are air-to-air heat pumps, but they also have water-to-air heat pumps connecting to a well and ground source heat pumps with pipes in the ground. One of my first jobs after college was developing and installing ground source heat pumps using a 300-foot heat exchanger inside a well. It worked great, except the well was too expensive. Now the technology is great. It's working. It's standard. So as part of my whole house electrification project, I installed a heat pump and replaced my old gas furnace, at the same time replaced my old air conditioning system. Lots of other advantages in terms of efficiency, comfort, and control of temperature. The project went very smoothly, fewer than 3 weeks from hiring a contractor to turning the system on. These upgrade projects, however, are pretty complicated, so we need an expert to explain how it's done. So it's my pleasure to have Alex Sennert with Supreme Air Systems here. His company's been installing these systems, thousands of these systems, for over 30 years. They're a local San Jose contractor, and they really know what they're doing. And his company was one of the first that I interviewed that actually understood the concept of whole house electrification. So welcome to the show, Alex.
Hey.
All right, first time on the radio. All right.
Yeah.
Okay. All right. So first, explain to us how an air conditioner works, and then we can kind of transition into heat pumps.
Yeah, well, to truly explain an air conditioner, I have to first kind of talk about the components of an air conditioner. There's a condensing coil and then an air handler, essentially. The condenser is a compressor and a fan, and the air handler is a coil and a fan. So what happens is you turn on your air conditioner, the box outside gets hot, the box inside, the air handler, the condenser. So the air handler gets cold, and the fan will then run over that cold coil to pull the heat out of the house. Basically how an air conditioner works.
All right, and so we can back up, change it, but that was like simple, good, okay. All right, so that's how we can cool the air in the house. We're just blowing the hot air in the house over a cold coil inside the house, inside the air handler, and then you get cold air in the house. That's great. How does a heat pump work?
A heat pump's basically the same thing. It just reverses the flow of the refrigerant, so it will heat the inside box instead of cooling it.
So we're blowing cold air outside, and then on the inside, there's a hot coil, and when you blow the house air over the hot coil, you're actually warming up the air in the house.
Yeah, basically.
Okay. Yeah, I guess that's what was happening in my house this morning at 6 o'clock when the heating system went on, which was basically just the heat pump. That's pretty cool. All right, so what are the different kinds of heat pumps?
Well, like you said, there's air-to-air, where we take air from outside and you're blowing it across the condensing coil to take the heat from outside, and then you're transferring energy from air to air is what an air-to-air heat pump is. The water-air is the same thing, but you're transferring energy from water to air. So like you use a well, drill down deep. That's where you get your water. You run it into the aquifers underground. And then we have water-to-water, typically used for radiant systems, but air-to-water is actually more efficient than water-to-water.
Oh.
And then, of course, there's ground systems, which are generally water-to-air systems.
So what's a ground system? I've seen those and a little bit of experience.
They're geothermal systems. So we use the earth as a heat exchanger, essentially. So you're either drawing heat from the earth instead of the air, or you're expelling heat into the earth. So you use the earth itself to store your energy.
I mean, the good thing about that is that, once you get about, 4 or 5 feet down underground, the temperature is about 55 degrees or so, unless you're like in the tundra in Alaska.
Yeah. Beyond 6 feet underground, it's static temperature all the time.
Right, so that's good. Now, just kind of as a digression, I remember the heat pumps used to not work when it was cold or they were very inefficient. What's changed with heat pump technology over the past 30 or 40 years?
Well, compressors are a lot more efficient now, and they have inverter-driven compressors that can modulate, that'll allow them to draw more heat and cool better. They actually can get down to negative 13 degrees and still operate.
Yeah, wow. The ones I installed back in like the early 80s, I mean, once it got down below like 30 degrees, you were just running on electric heat in the house. It just didn't work at all. So that's a big improvement. Okay, so we've got those different heat pump systems. The other big changes that I've seen, and this is just kind of travel around the world too, I see a lot of these in Asia, they have split systems and ductless systems. Explain what a split system is and what a ductless system is.
A split system is basically your normal conventional system. You have an outdoor unit and indoor. It's split as opposed to a package unit where you see in a lot of commercial buildings, the units on the roof, it's all as one. Or hotel rooms is where you see the package unit style, also P-tax in the window.
Oh, so that's that thing underneath the window that's always making a lot of noise or always at the wrong temperature.
Yeah, exactly.
Okay, travel too much. Okay.
Ductless systems or mini splits is what we're starting to call them now, because not all of them are ductless anymore. Actually, like what we installed at your house, it's a mini split, has multiple indoor units. And so you can have an air handler in the room or in the zone that you want, so you don't have to heat and cool your whole house. So you can just room by room zone everything.
And that's good because, like in my house, I got an upstairs and a downstairs. And in the morning, I want to heat up the upstairs. And in the evening, I want to keep the downstairs warm, and kind of vice versa in the summer. The way it used to be is I would have to heat the whole house or cool the whole house. And now I could just selectively cool those zones.
Yeah, so it saves you a lot of energy because you're not having to heat and cool the whole house. It also helps fix hot and cold spots in the house. So you have that one room that's, always stayed cold because it's more drafty than the rest of the house. You can put an air handler in that room just to keep it warmer and get rid of those hot and cold spot issues.
How do the controls on these things work? Does it work with like a conventional thermostat or one of the new internet connected thermostats?
Yeah, for most systems, we can put any thermostat you would want on it. It doesn't really matter. Some of them work a little bit better with their own thermostat, but most of them don't care.
Yeah. All right, that's good. All right, so the reason why I put the system in is I really wanted to kind of eliminate the greenhouse gas emissions. Plus, I wanted to save some money. So why are heat pumps better than a gas furnace? If somebody's got an old house like my house and they have an old outside air conditioning condenser and compressor and the thing's kind of on its last legs and they have a gas furnace inside, why is it a good idea to put in a heat pump rather than just, put in a new outside compressor and put in a new gas furnace?
Well, first of all, any new air conditioner you put in is going to be more efficient than anything that you had before. Mm-hmm. We've seen the technologies change so rapidly with heat pumps recently, where 5-10 years ago, we were seeing high efficiency was a 14 SEER system, which we can talk more about SEER in a minute. And now that's the lowest we can put in anymore. We cannot go below 14 SEER. So you're going to get a lot more efficiency out of it right off the bat. But then the absolute best way to save money on your system is going to be combine a heat pump with solar, because you get the heating is powered by the solar that you have. And so you're not having to buy electricity or gas, and heat pumps transfer a lot more energy per dollar than furnace can.
When I kind of look at the numbers, I mean, it's more electricity. Well, I think with a heat pump, you get like 3 or 4 times the thermal energy when you're running through a heat pump rather than just an electric heater. Right. Yeah.
So heat pumps are rated on energy transfer. That's what the HSPF is, about energy transfer. An electric heater is considered 100% efficient. Right. Now, nothing's 100% efficient, but the reason it's considered that is because every BTU that it creates enters your home. Mm-hmm. Well, exits the system. You have duct losses on a lot of older systems. But the heat pump can, for that same dollar worth of energy, can transfer 4 times as much energy. It's a coefficient of performance.
Okay. Yeah. COP.
Yeah. And so it's moving 4 times as much energy into the house than your electric resistance heater is for the same amount of power.
Okay. So that's what I was getting to. Let's say, so if you have a resistance heater and you spend $100 on electricity, you're going to get $100 worth of heat. If you have a heat pump, if you put in $100 worth of electricity, you'll get basically $400 worth of heat. Yeah. And so the math works out the way natural gas prices are and standard electricity prices are. It's about a wash.
Yeah.
But that's if you're paying, PG&E rates 30 cents a kilowatt hour for electricity. But if you put in solar, now it's like 7 or 8 cents a kilowatt hour for the electricity.
Yeah.
And so it's way, way, way cheaper than continuing to buy natural gas from, our friendly utility. So explain what these CES, EER, and HSPF ratings are.
Well, here's how we do efficiency ratings on air conditioners. Mm-hmm. It's essentially a math calculation for how much electricity it's going to use per BTU that your system is. So you take the BTUs that your system will put out or will take out of the house, and you divide it by the SEER, and that's how many kilowatts it's going to use an hour at max capacity.
Okay.
HSPF is essentially the same thing, but it's for a heat pump instead of an air conditioner.
Okay. All right, cool. So these are just good ways for you to kind of compare these things.
The higher the number, the more efficient it is.
Okay, good. All right. So, Alex, what's involved in the project to replace an old clunky gas furnace and a decrepit outside air conditioning compressor?
Well, to replace with a heat pump, the outdoor unit is simply pulling out the air conditioner and putting in the heat pump. Operates on the same electric circuit, same pad that it'll sit on, everything else. We have to wash the line set, but it's neither here nor there. The indoor unit, we cap the flue, cap the gas, and then put in an air handler in basically the same place. You want a conventional system. If you're going with the mini splits, it's a little bit more complicated, as we usually have to do a lot more ductwork.
So you just gave me an idea. I'm up on my roof thinking about how many solar panels I could put up, and I was working around the flue from the furnace. So that flue basically can be capped.
Yeah, you can completely take that off now.
Yeah. Now, you may be using, I think you guys might use some of the flue for a chase, possibly, for the lines, but I'm not sure. But the top of it, I'm just capping the darn thing. That's going to give me room for more solar panels.
Yeah.
That's great. All right. And then the other thing that was really surprised me is on the outside, I had this big cylindrical air conditioning compressor, and it took up a chunk of the side of my house. And the new compressor that you put in is this rectangular thing. It's higher and it blows air to the side. First of all, it takes up a lot less space. And second, after you guys put the system in, I thought it wasn't working because I couldn't hear anything. I mean, I didn't hear the compressor turn on and make that big noise. I didn't hear the fan. And then I kind of listened to the ducts and I didn't hear any noise coming out from the ducts. It's just really, really quiet. So that was pretty impressive. So the installation, went pretty smoothly. And I got a little bit more room in my garage. I got rid of that clunky old gas furnace. So let's talk about costs. What are just roughly ballpark? You don't have to be that specific, but comparative costs between a new heat pump system versus replacing the individual air conditioning and the gas furnace components.
For like type situations where you don't have to do a lot of ductwork, you're going to stay with that conventional design. The price difference is fractional. When we start getting into more of a mini split system, it becomes comparable to replacing all of your ductwork and the conventional system, but your price difference it's just not that much.
So that was one option, is just take everything, take the whole gas furnace, the air handler out, and then just put in the heat pump air handler. And it wouldn't be zoned, at least it would be, or it was zoned the same way it was before, but everything would have worked fine in my house. It would have been a little bit cheaper.
A little bit, yeah. And we can zone a conventional style design. It just requires a much more efficient, or not more efficient, it requires a modulating heat pump and air handler. Whereas most of the time when it's replaced, people are getting the single stage because they don't need the modulating for a lot of houses.
Right. Okay. It's about a wash. So if you're looking at replacing your furnace and you got an old air conditioner, or you got an old air conditioner and you want to just go greenhouse gas free, the upgrading to a heat pump is going to be about the same price as anything else, and you're going to have all the other advantages.
Yep.
All right, good. So we're talking about the costs, and it's about a wash. What are some of the other advantages of installing a new heat pump system?
Well, for starters, with a furnace, as they age, they start to become almost dangerous. Heat exchangers over time, they're no longer able to expand and contract the way they are when they're new. As rust and other pitting happens inside the heat exchanger, if it cracks, you start to have carbon monoxide and fire hazards in your house. With a heat pump, you'll never have that. It will become less efficient over time, but it'll never become dangerous. Mm-hmm. So that's a huge thing, because carbon monoxide's a big problem if you have small children or elderly in the home, because they're more susceptible to asphyxiation. And on top of that, the heat pumps tend to be quieter. They just run at a lower speed now with the newer designs. Other than that, again, anything that we can do with a heat pump, we can do with a conventional system, but heat pumps they're more efficient with solar in there.
It makes total sense. And then, the other reason is that there's no greenhouse gas emissions.
Yeah.
I mean, that's what's kind of interesting about the state's whole initiative on this, is that I think it's by 2050, we want to be zero greenhouse gas emissions. And that's going to be really hard to do unless we upgrade all the existing buildings. And that's what this will do. And a lot of times these upgrades happen when equipment fails.
Yes.
So that's the most economic. For everybody listening out here, I'm not recommending that you tear out your functional equipment and put in a new heat pump, although I'm sure Alex's company would love that. But wait till it dies. And then you say, all right, I'm not going to put in a natural gas furnace again. I'm going to put in a heat pump. And there's going to be big incentives for that. I'm not sure if we've got them yet, but there are incentives for things like hot water heaters. So when your gas hot water heater dies, you put in a heat pump hot water heater. And, just the math is, if anybody that's got a house, on the average, your hot water heater dies after 13 years. It just rusts out. There's heat exchangers, and then, you wake up in the morning, you see a puddle in the house or in the garage, and it's time to replace that thing. So lots and lots of advantages. Now, what about other changes that you need to make to the house? What are some of the other implications of putting in a heat pump system?
Well, there's some electrical changes. We do have to run a circuit to the air handler that wouldn't have been there for the furnace, because it needs 220 at the air handler, with the furnace only needed 110. And then there might be some ductwork changes, depending on which kind of air handlers go in. If it's a mini split system, we could go as far as getting rid of all of your ductwork, or just modifying ductwork to make it work with a handful of different zones.
Yeah.
Other than that, it's not anything.
When you guys modify ductwork, are there any requirements to make sure that the ductwork is well sealed?
Yeah, we have what's called Title 24 testing, and they have to be, on remodels, it's less than 10% leakage. On new construction, it's actually below 5% now. So we make sure your ducts are sealed real tight.
Yeah, and that's one of the things that you'll notice on older houses is the ducts have a tendency to leak, and you see this, crappy old duct tape, which I don't even think people in the HVAC industry don't even use duct tape. There's better tape that they use, but they leak.
Duct tape's actually not the code anymore. Because it delaminates after not a very long time. The newer tape won't delaminate as soon. And if you're ever curious if your ductwork's leaking, if you have the old yellow insulation, take a look at it, and anywhere there's dark spots, your insulation's acting like a filter and it's collecting dust as the air comes out of your ductwork rather than going to your vent.
So you see the gray, see a
the gray or black
spots
or anything like that.
Oh, and so that's interesting. I mean, I noticed that the duct tape, when I use it to put a blanket around my domestic hot water heater, it would kind of fall apart after a while. And so I've been using the silver foil back tape, and that stuff seems to be really good, although more expensive.
Yeah, it's a little bit more expensive, but it'll pretty much last forever, that tape.
Right. Well, but, for any home handyman knows that duct tape is essential for fixing anything that shouldn't move but happens to be moving. So you just always wrap it with duct tape and keep it from moving. And then, just another do-it-yourself tip. If there's anything that should be moving but doesn't have to be moving, what do you use? WD-40. So I've trained my children for that. They know they got to always have that. Okay. How much electrical capacity does a heat pump need in terms of amps or circuit breakers or things like that?
Well, it depends on what size heat pump we're putting in. Mm-hmm. Everyone's house is going to be a little bit different. Usually our amperage is between 20 to 40 amps. But again, the BTUs is what's going to dictate the kilowatt per hour. Mm-hmm. It's all on that SEER math calculation.
So most outdoor compressors are already on a 30 or 40 amp circuit.
Yeah. There's not much electrical change we have to do for outside. It's all only in indoor.
Right. So if you have an air conditioner outside, this big cylindrical thing that I had, that circuit's going to power pretty much almost any heat pump. Yeah. And then you just have to make sure that when the wiring is done, it's done. And you weigh the new wiring and refrigerant tubes when everything was kind of packaged together. So you just had to run one bundle of, I guess, 2 insulated pipes, maybe a control wire and 220, and it was all together. Run that up to the attic or run that into the crawl space, and then that was enough to power that air handler. I was really impressed. It went pretty smoothly.
Yeah, that is one thing special about the system that you put in. Those air handlers use 110 circuits, whereas a conventional style system will use a 220 circuit for the air handler. Oh, yeah. So it's a different electrical line that we have to run.
It's even less. Yeah. Even less wire. It's like number 12 or something. Okay. How did you get into the HVAC industry?
Well, my father was in HVAC before me. He started, I think, when he was 16, and then took over this company when I was 7, and I would go out on jobs with him when I didn't have school. He'd hand me a blower and say, clean this, while he did all the maintenance and servicing of the systems. In high school, I did installations for a while, and then now I've moved into the design department of the company, and here we are.
Yeah, that's pretty cool. How can people get in touch with you at Supreme Air Systems?
They can either call the office at 408-376-0406, or they can email me directly, alex@supremeair.net. That's .net, not .com.
It's boy, those URLs are tough to get.
Yeah.
Somebody probably has the .com, I'm sure, and you don't want to pay to get it. Right?
No.
All right. That's all the time we have on this week's Energy Show. Thanks, Alex, for joining us. It was great to have you here on the show and just kind of understand what's involved for people in homes and businesses also to upgrade to a heat pump system. And thanks to all of our listeners for tuning in. If you missed any of today's show, you can always go to our website at cinnamon.energy and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.